Hello everybody. This video is about feature importance for regression tree in Jupyter notebook. So let's go to Jupyter notebook, load the data, and begin our analysis. And the first step is to load the data, so loading the data set. To do that, we need to import class label, importing class SPD. Sorry, instead of importing, import class SPD. Then we read the data. The same data we used before for support vector regression feature analysis. Call it flag equal PD dot weight underscore comma separated value parenthesis. The data set is found in E. The directory I have here is E. Then there is a folder SL tech dots, then for data, then sorry, the data set is set to call flag, so the format is CSV. So we run. We need to make the codes reproducible. See the code 7. Then excuse me. The next step is to clean the data. So data cleaning. Data cleaning. We like to check for null values and not a number. To do that, type float dot is null parentheses dot sum parentheses. So it tells us that we have a quantity, not a number, in each of these variable except for G8F, which is ground heat flux. So we need to remove this. Removing the null values. So flat equal flat drop NA. Axis equal 0. And we check for null values. same code as we had before is now get some parentheses. So here we have 0 everywhere. So we can go ahead with our analysis. Now let's see the descriptive statistics. That float dot describe parentheses. Okay, we have the error. This is our output. The flooded error. Response variable. The error. The remaining variables here are the independent variables or predictors. So we have relative humidity, evapotranspiration ET. We have a precipitation P. AT stands for air temperature, SM stands for soil moisture, GHF stands for ground heat flux. If you want to see the correlation coefficient between the variables, type flood.core parentheses. So this is what we have, and we see the correlation coefficients. Probably there will be multiple relative between ET and AT. Air temperature and AT are highly correlated. So depending on the analysis, probably you need to drop one of them or perform the variance inflation factor to know that what you need to do depending on the threshold of VIF. So we need now to prepare for our output and input data. So this you need to import LS library, sorry, local library. Import local as LP. Let's start with the output. Response variable. Y. So Y, as I said, is the flooded area. So from the dataset flood, we take area. Let's see our Y. The first 5 rows is what we get. Now the input. The level of independent. or again predictors. X. So I said X is everything except area and the time. You don't need time here. In the data set we have time. Let's type float here. And type float. We have time and the area, but we are not interested in time. So we have to drop this also from the predictors. So float drop parentheses brackets, then static type, put, comma, put again, remove area, then axis equal 1. So let's see our the first 5 rows of the predictors. So this is what we get here: H, E, T, P, A, T, S, N, and G, H, F. Here, if necessary, as we see the correlation coefficient between air temperature and E temperature, which is 0.88, almost 0.9. If necessary, you can perform the variance inflation factor to see your threshold, and then continue with scaling. I made a video about that, so you can do that if necessary. Perform scaling and sorry, let's capitalize here, and variance inflection if necessary. So I'm not going to do that here, so I skip it and I go to the next step, which is splitting the data set into training and testing data set. For this we needed to import the function called train test split from scikit-learn model selection. Okay. So now we split the data. X train. X test. Y train. Y test equal train test split before X before Y. Take the test size equal a generate torque 0.25%, and then random state shake 50. Okay, now let's see the shapes of our training and testing data. And that shape X test that shape Y time that shape and the Y test that shape. Okay, this is the X train, 6 variables with 2995 observation. From S test we have 6 variables and 999 observation. This is that's our Y, yes, Y. And training data, so that's one dimensional array. And this one also for testing data. So Y train and Y test. So we are already good to go for our decision tree regression. We need to import the decision tree regression function. Decision tree regression function. Let's see. From scikit-learn.tree decision tree regression. Let's run. Template decision tree regression. Let's run this. Oh, regression. Sorry, it's regression. Decision tree regression function. So the regressor, I'm sorry about that. Decision tree regressor. Function, importing decision tree regressor function, then from scikit-learn.tree import decision tree regressor. We run this. Now we are going to instantiate the model. decision tree regressor. We have the arguments we are going to pass here. The first, we take the max depth, the maximum depth of the tree. I take 9. The second is the mean samples leaf. Then the mean samples split. I take 4. This is we should do that based on our analysis previously. So I decided based on the data set and what we have done before. And what else do I need to put here? The max feature. Max features. This is also important. Maximum features, we have 6. We take I take 2 for the analysis. What else do you need? Maybe the max leaf node. Maximum leaf node. Let's see, 60. So the model is already instantiated. Then we need to fit the model. So let me call it dt decision tree equal new model dot fit, and you are going to fit it on x and y. Okay. So let's type dt and see. Okay, this way to get decision tree. Okay, that's good. So let's go to the feature importance. Our main topic here is feature importance. So we first have the data, we clean the data, we split the data into training and the testing data set. We run the regression tree. Now on this model we need the feature importance. Okay. Let's say F. Let's get the feature importance first. importance equal dt dot feature underscore importances underscore. And now we print the importances. So this is what we get for the 6 variables per order. So we need now to have the summary of these importances based on the indexes of them. So summarizing the index of each feature. So for I, Y will enumerate feature importance F underscore importance colon print put X not each of the features colon or comma as you want to, percentage sign, percentage symbol, D, comma, we need the score, colon, percentage symbol, you take 5 decimals, and you go after the quotes, the percentage symbol again, you take the parentheses, and then we have our I and Y. So this is what we want to print. So here we will have our feature, we will have the index and the score with 5 decimals for each of the 6 features we have. So we run. This is what we get. The index 0, index 1, index 2 to 5. So we have 6 input variables with each of their scores in front of them. So the first equals yes, relative humidity, second evaporative transpiration, precipitation, air temperature, soil moisture, and ground heat flux. So this is the order here with their importances. So now we are going to plot the importances, plotting the importances. To do that, you need to import matplotlib as pyplot. Matplotlib import pyplot. And after importing that, we are going to plot the bars. So pyplot.bar parenthesis brackets x for x in length in the range, sorry, before that. Okay, x for x in range with the length of f importance f underscore importance after the concrete we need the importance. Okay, this bar here instead of BSR, I'm sorry. Okay. Let's edit the pyplot.show. Okay. It tells us that the feature in question 4 has the highest contribution. The most important feature is soil moisture. And we see here the soil moisture. And then followed by the feature in question 1. And then 3. 1 is evapotranspiration and the 3 is air temperature. Now we are going to plot the importances by order. So mean we are going to sort them from the highest to the lowest. So from the most important to the least important. So let's say importance is equal d.series parentheses or object feature importance then we have the index equal x dot columns then we need to sort. In largest we have 6 variables, then we need the bars, so we need to plot by choosing the kind or the type as bar. Sorry. Okay, so this is what you get. Soil moisture is the most important, followed by vapor transpiration, air temperature, relative humidity, ground heat flux, and the very important feature is precipitation. So this is on the whole data set. I put as dt equal model.fit on x and y. So this is the result we get. So as I explained it in the previous videos, if you want an x train and y train, you just come here, wherever you have x and y, you put xy train. And when you want to do test data, you just change accordingly. So from here to below is going to be train. So look at these values very well. You see they have changed a little bit. So here again we are going to change train because we are on training data, and here there is y here, so it's going to be y train. You may look at these scores. We are going to change. This is on the old data, we run this on the training data. Then we have here again x, so it's going to be x train here also. Okay, look. Feature 4 is the most important. X train dot column. It's 4 followed by 3, then 1. So let's look at this very well. The most is soil moisture, the least is precipitation in terms of importance on the whole data set. Now let's say on the training data set, is that will change? No, it's changed. It has changed. So now on the training data set, the most important feature is still soil moisture, but the least is relative humidity, not precipitation anymore. Before it was precipitation. Okay. So if you want on testing, we do the same. We change wherever we see x test x print, sorry, x print test. Then you run. And you look at the importances very well. Those are numerical values, so you need to compare them. You have data, the scores on training data is scores and testing data. Generally, what we want is to compare. This for comparison purposes, that's why I'm running this. So you have to have the model accuracy or model whatever you want on training and testing. Okay, so when you come here, you run. If you look at these variables very well, you see that these values, sorry, if you look at these values very well, you see that they have been changed. Test. Test. Here, 0.02. And 0.09. That's on training and testing. 0.01 and 0.07. See here again, we go on testing. Okay. The shift 4 is the most important. Cell measure. This is important. Probably has changed. Now you have 1, which is relative humidity. Okay, with this we are going to see things clearly because we have been sorted from the most important to the least with the name of the variables below. Still so much, then the list is rich, so almost the same. You need also to compare the variables that are in between the most and the least. So thank you very much for watching this video. I hope it will help some people in doing the research. This is for research purposes, so that's what I do on my data. I hope I'm sharing with other people. I hope it will help them. This is the first it was on linear regression. Third video. So the first video it was on feature importance for linear regression, the second for sports vector regression, none for regression 3. I will probably have one on random forest regression. So, and you will see it was on the same data set with the same output, but the inputs are not the same from linear regression. If you see all those videos, they are not the same. The most important to the least important variables are not the same depending on these algorithms. So thank you for watching this video. See you next time for another video.